Hello everyone, my name is Islam and this is my channel for physics. This is my first time to introduce this course which is related to the experimental physics in English, and we are going to introduce several experiments in English. So if there is any problems, mistakes in my accent or my English, so sorry for this. Uh, First, our first experiment is a simple pendulum, and we are going to know what are the main objectives for this experiment. First, we need to study the simple harmonic motion, and second, we need to determine the acceleration due to gravity using simple pendulum. So we need to know what is the pendulum. Pendulum consists of uh, now we need to know what is a simple pendulum. Simple pendulum is a consists of string and um, bob at the end of this string or suspended by this string. So if we displace this bob to this direction to be here, and here will be point A, which will be start point of motion or the movement. This displays distance is the maximum distance is known as amplitude. So amplitude is the maximum displacement from the equilibrium position. This position is known as equilibrium position, and this pop or this simple pendulum will swing if we lift it from this point to vibrate forth and back, so it will move in this direction and pass by the equilibrium position, reaching to the maximum distance here, and then we'll go back again to a point, assuming this is point P. So it will move back from P point to A point, and it will continue in this motion. This motion is known as simple harmonic motion. So when it reaches to point P, what is the main reason to make it go back into this direction and continue in this movement is known as restoring force. So the reason of the simple pendulum or the pendulum to continue in its movement is known as restoring force. And this force equals minus kx. So it will take time to complete one vibrations. And the time required for one vibration is known as periodic time. And there is another term which is known as frequency. And frequency is known as number of oscillations or vibrations per unit time. So when it will start its motion from this point and move to P point and come back to A point, this means it have completed one vibration. And if we want to know the importance of this time to our experiment, this is the main law. T equals 2 pi root of L over G. We need to determine this, which is known as acceleration due to gravity. L is this length, which is known as the length of string. And 2 pi is a constant, T is the periodic time. By looking here, we will find in this series some general informations like the uh, simple pendulum history started from Galileo experiment and other general information like the periodic time and frequency. Uh, Also, frequency frequency symbol is F, which is here, and frequency equals inverse of periodic time, which means 1 over t, and also periodic time is inverse of frequency, which means t equals 1 over f. The restoring force, and force symbol is f, which means minus kx, and here k is a constant and x is a distance or the displacement. So this is the simple pendulum here. This part is a stand, and the simple pendulum is this string with this mass suspended. So when we displace this simple pendulum to this point, it will be under its gravitational force, which equals to mg. By resolving this force or gravitational force, we will find it or resolve it into two parts, mg cosine theta and mg sine theta. And here is the tension in the string of the seed. Also, this is known as the length of the string, which is known as L. And here is sine theta, and here is the theta. And this arc equals to x, which is the displacement. So there will be some approximations and mathematics. First, the time or the periodic time equals 2 pi multiplied by root of m over k. So m is the mass suspended by a string and by string length, which is L. K is a constant. We need to know the value of this k or this constant. So we are going to check these mathematical steps. So F equals minus mg sine theta. And this is the restoring force. When theta is very small, so sine theta approximately equals to theta. And this approximation is related to theta lower than 10 degrees. So this means we can write this formula minus mg theta like this. So F is a restoring force equals to minus mg theta. And by checking this diagram, which means sine theta equals to x over L. So sine theta equals to theta, which equals to x over L. We need to know the value of k, so we may also know this part, which is the restoring force equals to minus k x. And this x and this x will be removed. This means k equals mg over L. Also, these negative signs will be removed, and k equals mg over L. By using mg over L instead of k here, so we will find periodic time equals 2 pi multiplied by root of m over mg over L. This M and this M will be removed together, and we will find the final expression of T equals 2 pi multiplied by root of L over G. To make this formula more easy for our graph, we will take the root on both sides. So we will find T squared equals 4 pi squares L over G. So the tools used in this experiment or the apparatus means a simple pendulum. And we may write this simple pendulum as a component like a spherical pendulum pop, long string, and supporting rod or stand. These are the components of the simple pendulum. Also, we need a meter scale or a ruler, and we need a clock or a stopwatch to measure or to record the time. How to carry out this experiment? This is known as experimental procedure. First, we need to measure the length of the pendulum in centimeters, and this will be measured in the equilibrium position. Second, we will split the pump to one side with a small angle and release it in order to allow the pendulum to vibrate back and forth. And by using our table, we will record the total time it takes the pendulum to make 20 vibrations. Why we need to make 20 vibrations? Why we will use the time for a single vibration? Actually, this is used to reduce the error in the experiment. So time for one vibrations equals to 220 over 20. So we will record the time of 20 vibrations and divide it by 20 to get the time of one vibration or one oscillation. After getting this time, we will take the square of this to get the value of T squared and make a relation between L, which is the length on x-axis, and T squared in second square over y-axis. We will repeat this step, which means we will increase the length several times, and in each time we will record the time of 20 oscillations and getting the time of one oscillation by dividing this value of T20 over 20 to get the time of one vibration several times. This step will be repeated with different lengths and getting different values of time. Finally, we will plot this relation between L and T squared. This is our table is used to organize our data. So we will plot a relation between L in centimeters and T squared second square. It will be a linear relation and slope equals delta T squared over delta L. So this slope equals 4 pi squared over G. Now we need to know the value of G, which will be 4 pi squared over slope. Finally, we will get the value of G, which will be in centimeter per second square, and the ideal value will be 980 centimeter per second square. But maybe you will not get this value 980. Maybe this value will be lower or higher. So there is an error range which may be 950 to 1000 centimeters per second square. This is the range of the right values of the acceleration due to gravity. Thanks for watching, and don't forget to follow my channel